Hi viewers, welcome to the video on drawing the stick diagram for MOSFET based circuits. The stick diagram is a simple sketch of the layout. It can easily be modified or changed or redrawn with minimum effort. It shows mainly active, poly, metal, contact and the N-well layers. And the layers are color coded. We can use colored pencils or colored pens. Active, poly and metal lines or layers are drawn with lines. It is not necessary to use rectangular diagrams. The contacts are marked with an X symbol. It shows the contact between metal and active, or it shows the contact between different layers. Instead of X mark, we can use filled circles or filled rectangles. N-well is indicated by a rectangle around PMOS transistors. Usually we use dashed lines. These are the symbols we use for drawing the stick diagram. When we are drawing using colored pencils, metal one layer is indicated with blue line, poly with red, N diffusion with green, and P diffusion with yellow. Metal we will be having more layers. If we have more layers, each layer of metal is used with different colors. But for simple circuits, these four layers are enough. If we want to draw the diagram, stick diagram in black and white, we can use these symbols. N diffusion is of this type, polysilicon is this type, metal is of this type, and contact of either we can use filled circles or filled rectangles. And buried contact is using this symbol. Some rules we have to follow while drawing the stick diagrams. The first rule is when two or more layers, if they are of same type and if they cross or it touches each other. For example, in the first diagram, a horizontal layer and vertical layer is touching each other. That means both the horizontal layer and vertical layer are interconnected. Similarly, in the second line also, both layers are of same type. It indicates that there exists an electrical contact. Another rule is when two or more sticks of different types cross to each other, it is not electrical contact. That is, in the first diagram, if we see the horizontal line is of blue metal and vertical one is red polysilicon. It is crossing, but it just crosses means it doesn't indicate there is a contact between a metal and polysilicon. In the second diagram also, N diffusion and metal is crossing, but it doesn't indicate there is a electrical contact. If electrical contact is required means we have to indicate the connection explicitly. It is shown in the bottom two figures. Here the electrical contact is shown in the joining point of the horizontal and the vertical layers. So it indicates a metal layer is in contact with the vertical polysilicon layer. Similarly, here horizontal N diffusion is in contact with the vertical metal layer. So if the contact is there means it should be shown explicitly. Here another thing is whenever there is a polysilicon layer crosses a diffusion, it represents a transistor. In the first diagram, the polysilicon is crossing N diffusion. So this one shows NMOS transistor. In the second diagram, the polysilicon crosses P diffusion. It indicates PMOS transistor. So whenever there is a crossing of polysilicon and diffusion, it indicates a formation of transistor. If contacts is shown in between the two layers, polysilicon and diffusion, then it indicates that it is not a transistor. So bottom two figures are not transistor. The top two figures represent transistors. Another rule is if we want to differentiate N diffusion and P diffusion, we can draw a demarcation line of this type. It is not a mandatory one, it is optional. We can draw the PMOS transistors above the demarcation line and the NMOS transistors below the demarcation line. So this symbol, that is crossing of P diffusion and polysilicon, represent a PMOS device. The bottom one represent crossing of polysilicon and N diffusion. It represents a NMOS device. While using colors, we can easily identify N diffusion and P diffusion. When we are using black and white diagrams, that time it is difficult to differentiate N and P. So we can identify the transistors at the top is PMOS transistors. Transistors at the bottom are NMOS transistors. That a demarcation line can be drawn in between two transistors and it is an optional one. So when we draw the diagram for MOS devices, the first top diagram is an NMOS device. It can be drawn N diffusion, a horizontal N diffusion, a vertical polysilicon layer. One side we have, both the sides we have N plus regions. So we can have source and drain regions on the two sides. Similarly, for PMOS device, we can have a P diffusion, horizontal P diffusion, vertical polysilicon, and we get P plus regions on both the sides, and they are source and drain regions of PMOS device. So now we will see how to draw a stick diagram for inverter. We know the diagram of inverter. One PMOS, gates are connected together, we apply input. Drains are connected together, we take output. Source of PMOS is connected to VDD. Source of NMOS is connected to ground. That is the basic inverter circuit. The stick diagram is not having any dimensions. Maybe the ratios can be indicated near the transistors. Only the interconnection is important. That is, the topology is important, and final layout can be generated by a compaction program. Now we will see the drawing the stick diagram of inverter. The first step will be drawing the VDD line and VSS lines. So VDD and VSS, that is ground. Ground is also called VSS line. VDD line and ground lines will be of metal. So we are using metal layers horizontally, VDD at the top and ground at the bottom. Two lines, metal lines, one for VDD, one for ground, are drawn. Next we use P diffusion for P channel near VDD, N diffusion for N channel device near ground. So P diffusion and N diffusions are drawn. Next, polysilicon crossing is to be drawn. So the top one represents P channel device, the bottom one represents N channel device. And the gate is of polysilicon material. Okay. The gates are connected together and we have to apply input. To give the connections, it is not necessary to use metals. We can use polysilicon also as a wire. So we can join both the gates together and apply the inputs. So here the gates of P device, gate of N device are connected together through polysilicon and we can apply the input here. And to connect the drains together, we can use metal lines. And we need contact cuts. So here we are using metal lines to join the two drains of both N device as well as P device, because it is N material, this is P material, and the connection is of metal, so contacts are to be shown. So here the contacts are shown, output is taken, and then the source of PMOS is to be connected to VDD, source of NMOS is to be connected to ground. So we can draw the metal lines. Here both are metal, so contact is not necessary, but here the connection is to be shown because it is N diffusion, it is metal. So these are the steps for drawing the stick diagram of inverter. The same steps can be applied to all the circuits. And when we are drawing the stick diagram, this is not the only method. Here we have drawn the diffusion layers vertically, polysilicon in the horizontal mode. Instead of it, you can draw diffusion horizontally and polysilicon vertically like this. This is a diagram we have already seen. We can draw like this is the another option. When we are drawing stick diagram, it is not that we always use same type of or only one way of drawing the stick diagram. We can use different methods. Here the diffusions are shown horizontally, polysilicon is drawn vertically. Even we can extend the polysilicon here and apply the input in at the bottom also, at the bottom or top. The top metal layer is VDD, bottom metal layer is ground. Output is taken here. So it is not the only way of drawing stick diagram. We can draw by any ways. Now let us see the drawing the diagram of stick diagram of NAND gate, two input NAND gate. The two input NAND gate will be having two transistors in series in the pull down, two PMOS transistors in parallel in pull up. The same circuit is redrawn here to draw the stick diagram. Here we see the source of transistor B is connected to ground, drain of transistor B is connected to source of transistor A, and the drain of transistor A is connected to output. And the sources of transistor A and B of PMOS devices are connected to VDD line like this, and the drains of A and B PMOS transistor are connected to output. Now, first we draw the metal lines, VDD and the ground. Top one is VDD metal line, bottom one is ground metal line. Then we draw the P diffusion. We draw a P diffusion, a long line to accommodate two PMOS transistors. Similarly, two NMOS transistors for N diffusion. Then we draw the polysilicon gates. One is applied with input B and another in polysilicon line is applied with input A. And the source of B transistor of NMOS device is connected to ground through metal line, that is this one. And we draw other connections. Sources of PMOS devices are connected to VDD line. The source and drain of MOS devices are same. We can both are of same size, same doping concentration, everything is same. So we can choose either side of the polysilicon as source or drain. So in the top, the center portion of the two transistors are considered as source. Then we are connecting the drain of two transistors, that is transistor A, transistor B drain of PMOS devices, and the transistor A drain of NMOS devices. All are connected together like this. And we have to put the contact points. So wherever we are having different materials, there we have to include the contact points. If we see this portion represent source of NMOS device connected with the input B, drain of transistor input with the input B. It is connected to source of transistor with input A, and the drain of this one is connected to output line. Similarly, in the PMOS devices, this is considered as drain of transistor B, and this is the drain of transistor A. Both are connected together and connected to output line. transistor A and B of PMOS devices, sources are considered in the center region and they are connected to VDD line. So to ease the connections, we are drawing the stick diagram of NAND gate like this. Similarly, we can draw the diagram in the black and white like this also. This is the stick diagram of 2-input NAND gate in black and white. Let us see the drawing the stick diagram of NOR gate. NOR gate is having two NMOS devices in parallel in the pull down and two PMOS devices in series in the pull up. So the procedure is same. We draw the VDD ground lines, P diffusion, N diffusion, polysilicon lines, and then we can have connections like this. Only difference is between NAND and NOR is the connections of NMOS and PMOS devices are interchanged. Other things remain same. So here, if we see here, this is bottom one is ground line, top one is VDD. This is transistor with input 1. So this is drain, this is source, and for this transistor, this is source and this is drain. Similarly here, it is source of one transistor connected to VDD, drain, source, and drain. Source of next transistor connected to output. So source and drain are same in case of MOS devices. Accordingly, we can choose source and drain. We can choose either side of polysilicon as source or drain. It is not necessary to fix source and drain. We can interchange. It is not the only way to draw the diagram. We can draw this way also. Here, this is another type of connection. Two NMOS devices in parallel. Two separate N diffusions are shown. Two PMOS devices in series. Here the connections are taken. Only thing is we need more layers, because if I take this polysilicon A input directly here, we will get another transistor here. To avoid it, we have to use metal line, because there should not be unnecessary crossing of polysilicon and diffusion. So to avoid the unnecessary generation of the transistors, here we are using metal. Here also we are using metal. If we use same polysilicon, then it will form extra transistor or it will show short between two inputs. If we use polysilicon here, means it is a short between A and B. So we have to use metal layer. So there is not only one way of drawing any stick diagram for any circuit. We can draw it in different ways. Only thing is we have to follow the design rules and we have to draw without or minimum error. Mostly without error. It should clear the design rule check. When we are projecting the layout from the stick diagram, it should not have any DRC error. With this, we have seen the stick diagram of NAND and NOR gates. If we want to see the stick diagram of other circuits, first we have to draw the CMOS diagrams. With the respect to CMOS diagrams, we can draw the stick diagram. So power, ground, and then P diffusion, two devices in parallel, one device in series. So it is drawn like this. In the pull down, two in series and one in parallel. So initially this connection is drawn and then we can have polysilicon. Whenever you want to have crossing of polysilicon and this one, means we have to use metal layer. Here you should not extend this polysilicon up to this point, because if we extend, we will get one more transistor with input C. Then we will have three transistors in series. To avoid it, we have to use metal here. So we see that there should not be any unnecessary crossing of diffusion and polysilicon. This is how we can draw the stick diagram for different CMOS based logic circuits in the VLSI design. With this, we complete the drawing of stick diagram. Thank you.